Welcome everyone to our first workshop here at Akave Cloud with as goal to showcase how easy it is to migrate from AWS S3 to Tamper-proof cloud. Today, we're going to give a quick update on what Akave is. We'll talk about the benefits, and then we'll have Abe showcase how to migrate data from AWS bucket into an Akave bucket, and then end up with and close it down with a summary. Who are we? So today, there's no single conversation that can be had without bringing up AI. We're living in an AI agentic era, and all of this is fueled by data, whether it's hyper-personalization or augmenting our day-to-day activities. It's essentially fueled by it. But unfortunately, the current storage infrastructure is outdated to support these new AI workloads. And Akave is how it breaks free. And why is that? Because cloud wasn't built for what comes next. And why is that? Because cloud is expensive. Not only is it expensive and pricing hasn't changed in 8 years, it's also complex when you want to move data out of the cloud, when you want to use multiple cloud stacks. So it's not flexible. It's easy when you stay within that cloud provider, but once you start using other technologies, it becomes very expensive. We see a lot more users looking at on-premises. We're seeing users that care about guaranteed immutability. And some of these solutions that exist and can offer this are very proprietary to the cloud solutions that you're acting or that you're operating in. And so vendor lock-in is an issue. And it's something that we help customers with to break free from. And third is data privacy. Once your data is stored in the cloud, what we're seeing is that there's an increased ransomware attack. There's also the concern that data can be read by cloud providers. And so all of this requires a new infrastructure. And on top of that, with AI, or I would say smart ransomware or AI-enabled ransomware, because ransomware is evolving as well. There's a lot more bots that are actively attacking your infrastructure. There's newer ways to attack and also impact your data infrastructure. And so how do you make sure that your data wasn't changed? How do you make sure that there wasn't any malicious data injection happening, there was extra data added into the data sets that were used to train your LLMs? How do you verify all this? And this is where Akave comes in. Akave Cloud 03 is a verifiable, immutable, programmable storage that's S3 compatible. So what we've seen in the last couple of years is that users want to maintain the same APIs, which is the S3 APIs. So it works with their existing Web2 applications. They obviously want high cost savings. Who doesn't want that? But most importantly, they want to get rid of the egress cost, because with the higher usage of existing data sets, users are getting more affected by these high egress costs. And what I mean by that is that a lot more businesses are looking at AI to improve their user experience, improve their cost structure. And for that, they're using their data sets. And so as you're using those data sets and you're using external compute, you're actually getting taxed with these extra egress costs. We call it the cloud tax. And then third, we see a world where immutability should be a default feature, and not shouldn't be a feature. It should be a default design, part of the architectural design. And so with Akave, we've made sure that every single transaction, every policy, every action on a data set is stored immutable and is verifiable, meaning you can verify it, you can guarantee, and it's stored immutable, so you have proof that something happened, that something was stored in a certain location, etc. And then last but not least, user-controlled data sets, meaning with these AI agents that are acting agentically, we also need to provide APIs that allow automation that's driven or that's enabled by these AI agents to more easily be implemented. And so with our APIs and our data wallets, we offer some of that flexibility built into the stack. So what are we offering? We're offering a tamper-proof storage. What that means is we allow for any data to be stored in a tamper-proof way. And the way we do that is by combining unique content-addressable hashes. So instead of pointing to an object just by its name, it's actually validated and verified with its unique hash that is based on the content itself, plus an immutable ledger that is verifiable, meaning it is by default stored in a ledger that keeps track of all these transactions. And we'll show that in the demo today. So what that means is that with Akave Cloud, we have tamper-proof during transfer, we're tamper-proof at rest, tamper-proof at execution, and tamper-proof audit trails as well, built in. Where in the cloud, you're sort of locking yourself in with an object lock feature, which locks in objects in AWS or locks in objects into Azure or Google Cloud. But as soon as you want to move data out of the cloud, you have to unlock that and you have to pay for the egress, where in Akave Cloud, this content-based hash is used, not a vendor-based hash, and it's immutable by default. And you can still move data across multiple zones in the Akave network without having to pay extra or change it from an immutable to immutable format. A third is that you can run your execution in a TE of choice, trusted execution environment of choice. Plus, we'll see that today, we also have immutable logs real time, which means it gives you full transparency and observability that you need to guarantee that you can prove that data was actually stored or removed or located in a certain location. All right, I'm going to pass it on to Abe, who's going to give us a short demo, share with us the Explorer and how immutability is tracked. So Abe, go for it.
Yeah, thank you, Stefan. Hello guys, I'm Abe Upadhyay, software engineer at Akave, and let's deep dive into technical details of how Akave let's deep dive into how it works under the hood. In coming minutes, we'll see how Akave is technically different from centralized cloud storage providers, but with a familiar web S3 interface, and how can you migrate the data from other S3 providers like AWS to Akave using familiar tools such as Rclone. To set a context for upcoming demo, I'll be using Rclone as a migration and replication tool to move data from AWS bucket to Akave O3. When receiving the data, the metadata itself is stored in immutable ledger, that is blockchain, and data itself is chunked and stored across the decentralized hot storage network. So any action taken by either the client or the node providers is logged on chain and can be seen on our Explorer, which I'll be demonstrating later. So let's begin with the demo. So to begin with, we'll use AWS CLI with Akave O3 to demonstrate feature parity with S3. So let's just simply create a bucket. Just FYI, I have already configured my environment. So you can see I have a profile called Akave Rclone already set up. So that's out of scope for this for today's demo. If you need help regarding that, you can follow our docs at docs.akave.xyz. So I'll go ahead and use S3 CLI to create a bucket on Akave. So we just created a bucket on Akave using AWS CLI. Now let's use Rclone to move over data from AWS S3 to Akave O3. I've already configured remotes in Rclone. So you can just use command rclone config to set up multiple remotes. I have 2 remotes here with Akave O3 and Akave S3. You can just use this command, create a new remote, and just follow the prompts on your CLI. So now I'll move over data from AWS bucket to Akave bucket that we just created, named Akave Workshop. So we just migrated data from AWS S3 to Akave. Let's just quickly list buckets. AWS CLI list data in this bucket so we can verify that. So as you can see, this was the data that was in that bucket. Actually, I should use a file with a better name. So I'll migrate using a different bucket, that is this one, which has a 1 megabit file, not too complicated file name. So it's easily readable. As we can see, a new file was uploaded that is test-1 megabit.txt. So we just migrated over the data from AWS S3 to Akave O3, but a question might arise that what happens to my data once it's uploaded using S3 interface to Akave. So let's deep dive into that. So when a file is first uploaded, chunked into 32 megabits chunks, and then each chunk is split into data blocks. These data blocks are then encrypted using a user-provided encryption key. And this encryption data blocks are then distributed across the nodes to achieve high resiliency. So even though individually participating nodes do go down in future, we'll be able to recover and retrieve your data from the remaining nodes. So now let's go to our Explorer and just...
And this Abe is like the immutable ledger, right?
Yes. So public Explorer can be considered as an immutable ledger where every action taken by either the client or the server is stored and visible.
Right. So here you'll see all the transactions in the files. There you go.
So this is the 1 megabit file that we just uploaded. So one more thing, the actual size versus the encoded size. Encoded size is including the erasure coding and the encryption overhead. So we can verify the redundancy here, and we also see the version text in front of the file name because the versioning is enabled by default. I'll soon demonstrate the same using CLI by uploading a different version of the same file to the same bucket. Now we can also see a bunch of filled chunk blocks. So as we saw in previous slide that the file is split into chunks, and these chunks are received by the nodes. And as they store these chunks, they also send a transaction on chain. So the log is maintained on chain that the node has been storing your data. Now back to CLI. Now what we'll do is create the random file again with the same name so we can ensure that the data has been changed. Just a second. I'm just verifying this size. So I'll upload this file again. That is a new random file with new data. So when I upload this again, this would be considered a new version of the same file, which can be verified using the CLI. So let's do that. We'll use S3 API CLI list object versions. We'll do bucket name and file name. Oh, did I spell it wrong? Version of file Akave. As we can see here, the file exists with two different versions. The first one with version tag v1 and the second one with the version tag v2 that we just uploaded. So now let's download a specific version of this file. The API get object, everything else remains the same. Just we add version ID v1 and output test 1 meet. Yeah. So we just downloaded the v1 of the file. This is just to show that the versioning is enabled by default in Akave. In other S3 providers, you have to go through various hoops to enable this, and the logs can actually be seen on our Explorer. So this was the version 2 of the same file. So that's it. From me, I'd like to hand over to Stefan again to continue the workshop. Sorry. So before handing over to Stefan, let's just quickly recap what we just did. We started with data in AWS S3 bucket. Then we migrated that data from AWS S3 to Akave O3 using Rclone. So the immutable hash on Akave Blockchain Explorer, we uploaded a new version of same file, demonstrated immutable data versions, tamper-proof verifiable audit trail for all bucket and object activities. So that's it from me. I'd like to hand over to Stefan.
Awesome. Okay, thank you, Abe. So now that we've seen how you can easily migrate data from AWS Cloud with Rclone, yes, Rclone is very command line focused, but we also have other applications that we integrate with. Before we end the call here, I just want to confirm that it's very important to understand how we get to those cost savings, because we can save up to 80%. And that's because we don't charge for egress costs, which means that you can retrieve your data as often as you want. There's no hidden fees, and there's a flat pricing of $14.99 per terabytes per month. To Abe's point, like, yes, our S3 API is Amazon S3 compatible, which means that it works with other applications. One of those applications is Snowflake, a very well established compute servicing or SaaS offering specifically for analytics and AI. And we'd also integrate with Iceberg. This is an example of a customer that has moved data out of the cloud and could save up to, or has saved up to more than 56% over the next, more than 56% over the next 2 years. And one thing that's important here to understand as well is that egress fees, because we're not charging for that, is one of the biggest cost savings, even outside of the lower absolute cost of storing data. If you want to join us, if you're interested in a custom demo, please reach out to us, because we have many of these applications that we're qualifying with. We have Disk Mounter, we have VLC, We even have an MCP server to interact with your data and chat with your data. So please let us know if you have any questions, if you want to set up a demo, or join us at our Telegram, Akave Builders, and stay up to date with the latest technical updates.